Alright, talking with Chris again from YSI, and we're going to talk about the EcoMapper Autonomous Underwater Vehicle.
Okay, great, Doug. Thanks. Good to see you again. So this is our EcoMapper AUV. It's actually a variation of the Ocean Server AUV platform. We've worked directly with Ocean Server to do some enhancements to the vehicle. So we've integrated in some of our own components. As you likely know, some of our core sensor technologies include acoustics for Doppler profiling, as well as water quality. So we've developed a 10-beam DBL that has an uplifting beam for detecting ice surface or water surface. It has a downlifting beam for detecting the bottom for your bathymetry data, as well as 4 downlifting beams for water current profiling and bottom tracking, and 4 uplifting beams for water current profiling as well. So you actually get water currents above and below the vehicle, as well as your bottom tracking and your bathymetry data. The nose cone of our EcoMapper AUV, which was built in conjunction with Ocean Server, consists of our standard 6600 V2-4 solid. So it has 4 of our optical parameters, plus conductivity temperature, and pH or pH and ORP. So on this unit, we're running our dissolved oxygen sensor, we're running chlorophyll, blue-green algae, and then turbidity all at the same time. And we're getting these samples at a 1 Hz rate. Okay. So we have water quality, we have water currents, as well as the Doppler velocity log for bottom tracking. And then moving back to the core of the vehicle, we have side scan sonar, so it's an imagenic side scan sonar. We have a HUI modem on here, an acoustic modem for communication underwater. We have the GPS antenna that also has a built-in Wi-Fi receiver as well as a spread spectrum radio. We're using that for communication with the vehicle, for mission planning, as well as for taking remote control of the vehicle and actually driving the vehicle. This vehicle has our extended payload package on it, which allows you to port in additional third-party sensors, and there's a secondary CPU in here that's separate from the main driver CPU, so you don't mess with the mission control at all when you integrate in your third-party sensor.
Okay.
And then, of course, we have the fin control and the prop, and then this is the safety tow float. So the safety tow float gets towed behind the vehicle. We find it has actually no impact on the vehicle performance whatsoever. And inside here is a series of electronics with logic built into it that ties back into the mission safety as well. So if you're not making forward progress or if you're stuck, this will actually blow. There's a CO2 cartridge in here that inflates a rescue sausage to let you know where the vehicle is. And ideally this will float the vehicle up to the surface as well. You can also set this safety package up to blow that rescue sausage when you're in the park circle at the end of your mission. So if you're in a high sea environment, if it's rough seas, you have this big yellow sausage kind of flopping in the wind, which will help you identify the vehicle visually a little bit easier.
Okay.
Communication with the vehicle is done wirelessly. So the vehicle comes with just a standard Wi-Fi router, basically, that we have developed here with Ocean Server. So the box has the Wi-Fi receiver in it, plus the 900 megahertz spread spectrum radio. And you communicate with the vehicle through this box through your computer. So your vehicle basically appears as another computer on your network. The vehicle itself is actually running embedded Windows XP, which is an incredibly solid and stable platform made by Microsoft, one of the few. So the vehicle appears as another computer on your network. You do your mission planning, and then once you have your mission planned out, you simply drag and drop your mission file over to the vehicle to put it on the computer. And then you remote desktop into the vehicle. There's a control software that resides on the vehicle, and you take control of the vehicle through remote desktop, and you can drive the vehicle on the surface and then start the mission and send it on its way.
Okay.
And if we walk around and look over Ben's shoulder, I believe Ben's working on the mission planning software. So Ocean Server's developed this vector map graphical interface for the mission planning. And you basically have any geo-referenced image that you can bring in. In this case, we've used a NOAA chart with the satellite image overlay in this section over here. And we're simply dragging and dropping points along the map to plan out our mission. And between the points, you'll tell the vehicle whether or not you want it to dive, whether or not you want it to undulate through the water column, how far it should be off the bottom, how far it should be below the surface, and whether or not you're running the side scan sonar. Okay.
And what's the endurance of this vehicle?
This vehicle can run at about 4 knots for 8 hours.
Okay.
That's sort of the max endurance of the vehicle.
And does it run standard alkaline batteries, or is that rechargeable?
There's actually a proprietary lithium battery inside of here. Ocean Server's developed batteries for this thing that actually have very high capacity and very high charge capacity rate. They hold their charge quite well. And you actually have the ability to shunt those or deshunt those batteries for shipping, so you can ship the batteries inside the vehicle, which is nice. You don't run into issues with your batteries ending up in one place in your vehicle, ending up somewhere else.
Okay, so about 3 or 4 knots as far as speed, and about an 8-hour endurance, and that's with everything running?
Yes, that's correct.
All right. Well, thank you very much.
Okay, great. Thanks, Doc.